Hello guys, welcome in today's session. I am Professor Fayaz Karadi from Department of Mechanical Engineering. In today's session, we are going to learn how to find the magnitude as well as the direction of gyroscopic couple from unit number 6 gyroscope from theory of machine subject. Remember, any system subjected to gyroscopic action if the spin axis of a rotating body is made to precess. This would create gyroscopic couple acting on a rotating body. See here, a rotor is spinning about the axis OX. That spinning of the rotating body, either it is rotating in clockwise direction or anti-clockwise direction, you can see in which plane. That plane is called as a spin plane. This is the position of the observer, and from this position the observer can directly see the exact rotation of the rotor and in which plane. That plane is exactly perpendicular to the observer. That plane is called as a spin plane. At the same time, the rotor is rotating about the axis OY, and through the distance rotation delta theta. That delta theta you can see from top view, and the plane in which you can see that rotation about OY of a spinning body. That plane is called as a precision plane, which is a perpendicular plane to the spin plane. Spin plane and precision plane are perpendicular to each other. So whenever any body is spinning as well as it is precessing about the axis, that body is subjected to third force, which is active force. If that body is rotating, spinning as well as rotating or precessing, that body is subjected to either tilting of right side or left side. And that tilting you can see in third mutually perpendicular plane. That tilting you can see in that plane. That plane is called as a gyroscopic plane. When any body is spinning as well as at the same time it is rotating, the active force, that body is either move downward direction or move upward direction. That motion, that moving of upward or downward direction, this is due to the force which is acting on that body. That is nothing but active couple. And the active, to compensate that active couple, you are applying the force is nothing but a reactive or gyroscopic couple. A reactive or gyroscopic force, which you can see in third mutually perpendicular plane, and that plane is called as a gyroscopic plane. This concept we can easily understand, and the best example of understanding this gyroscopic couple is our table fan. The blades of the table fan is spinning about the horizontal axis, as well as at the same time that fan is precessing also. That precession you can see from top view, and the precession axis is a vertical axis, and that precession you can see in precision plane or bottom plane. This is the best example. So when there are two motions, spinning as well as precessing, that fan either moves downward direction or it will move upward direction due to the active force. And to compensate that, the mechanical device which is known as a gyroscope is fixed in the rotating fan also, in table fan also, which compensate that active force and apply the reactive or gyroscopic couple. Due to that device, the fan is rotating horizontally, exactly horizontal. It is not moving upward or it is not moving downward. The same experience you can you experience that whenever you driving a motorbike, the wheel is spinning about the horizontal axis, and that axis is nothing but spindle of the wheel. And you, if you are taking left turn or right turn, that is nothing but a precision. So that gyroscopic couple you will experience while taking the turn for on the motorbike. You have to slightly tilt that vehicle either left or right towards the center of the rotation or away from the center of the rotation, and that is nothing but you are applying the gyroscopic couple while taking the turn during driving the motorbike. So in most of the example, you experience that gyroscopic couple. So in today's session, we have to understand how to find out the magnitude of a reactive force, and as it is a vector quantity, to find out, we have to find out the direction of a reactive couple also. The magnitude of the active couple we are going to find out, and the reactive couple is having same magnitude but opposite in direction. So first of all we have to find out the active couple, and after that the magnitude will be same for the reactive couple, and we have to find out the direction of a reactive couple. As per the given data in the problem statement, we have to find out the magnitude and direction of a reactive couple, because in gyroscope, active couple is not working, a reactive couple is working. So gyroscopic effect is the effect of a reactive couple or reactive force. So understand this, expected that you understand the what is a reactive couple and how it acts on the rotating or spinning body. So a reactive couple, again I am repeating, the reactive or gyroscopic couple is acting only when the body has two motion. One is a spinning motion, at the same time it is recessing motion. Spinning motion and a rotating motion. Spinning motion you can see in spin plane, a rotating motion you can see in precision plane, and tilting motion or a reactive or gyroscopic couple you can see in third mutually perpendicular plane, which is gyroscopic plane. So whenever you will solve the numericals on gyroscope, you have to clearly understand which is spin plane, which is precision plane, and which is gyroscopic plane as per given condition in the problem statement. Now let us start to find out the magnitude of gyroscopic couple. Consider the disk spinning with angular velocity omega. This is the disk spinning with angular velocity omega about the spin axis OX. This is spin OX in anticlockwise direction. When your position will be left side while looking that image, when seen from front. So this position of the observer is the front position. Why? Because you can see the actual rotation of the rotor. So this will become the front view or position of the observer. This is the first position of the observer in which you can see the actual rotation of the rotor. So perpendicular to you, to your eyes, is the spin plane. Okay, when seen from front, let angular momentum is I into omega. Angular momentum of this rotating body is I into omega, where I is mass moment of inertia of this about OX in kg meter square, and omega is the angular velocity of this in radian per second. As the angular momentum is the vector quantity, it may be represented by vector OA, as this is a vector quantity. Angular momentum is a vector quantity So it have direction as well as magnitude. So it is denoted by vector OA, I into omega. Angular momentum of this rotating body OX is the spin axis. So OA is the vector OA. Then spin axis OX rotating anticlockwise when seen from top about the axis OY. This spin axis OX, this spin axis OX is rotating about the axis OY, about the axis OY in clockwise direction when seen from top. Now your position will be here, seen from top. Okay. Let OX is turned through a small angle delta theta. Delta theta is the small angle through which that rotating body, spinning body or spin axis is rotated. And the new position of that axis is OX dash. OX dash. Okay. Let the OX is turned through a small angle delta theta to the new position OX dash in time delta t seconds. The angular momentum will be represented by vector OP. That angular momentum, now the new vector O for new position OX dash is OB. OB in this direction, OB. Now, how to find out this direction of this vector from O to A? By a right hand thumb rule. If that curling fingers is showing the direction of the rotor, curling finger, this rotor is rotating in anti-clockwise direction from this direction. So curling finger, the tip of the curling finger is showing the direction of the rotation. The thumb will shows the direction of vector OA. So from right to left, from O to X. See, this is the direction of thumb. When curling finger, tip of curling finger is showing the direction of rotation of a rotor. So the arrow is showing from O to A, not from A to O. Okay. Now the direction of OX dash or the direction of vector OB dash. OB dash is why O to B? Because the curling finger is showing the direction of the rotor. At the same time, the thumb is showing the direction of this vector. As we learned in previous session, I will share the link of previous video. O to B. This is the direction of vector OB as per a right hand thumb rule. Okay. Now, the rate of change of angular momentum. Rate of change of angular momentum is equal to OB minus vector OA. OB, vector OB minus vector OA, that is nothing but a rate of change of angular momentum. OB, final position, minus OA, initial position, is equal to vector AB. Vector AB. That vector AB is an active couple. That is a active couple which you can see in third plane, gyroscopic plane. Okay. But we have to find out the reactive couple. Reactive couple. Okay, A to B. A to B. Now what is A to B? A vector AB. Vector AB is equal to vector OA into delta T. I into here I into omega. Angular momentum of AB. I into omega. Okay, so I into omega is nothing OA, vector OA into how much distance, how much angle through which it is rotating, that is delta theta. Okay, omega. This will become omega in precision plane, or we can see omega P delta T. Okay, but vector OA is equal to I into omega delta T. Delta T. Now the rate of change of angular momentum is equal to I into omega delta t by delta t, delta theta by delta t with respect to time. Now the rate of change of angular momentum will result by application of couple to the disk. The rate of change of angular momentum will result by the application of couple to the disk. Hence, the couple or torque applied to the disk causing precession is equal to torque is equal to limit delta t tends to 0 I into omega of this term, I into omega into delta theta by delta t. This is a small value, so I into omega into d theta by dt. And what is d theta by dt? That is nothing but a omega, again omega, but omega of what? Omega d theta by dt with respect to small time. Okay, what is d theta? This is omega again, but this is omega of spinning and this omega about precision. So omega precision. So the formula will become here to find the torque or a reactive couple is equal to I into omega precision. Omega precision into Newton of, and unit is Newton meter. Torque is equal to I into omega p, and this omega is equal to omega angular velocity of spinning, and this is angular velocity of precession. Angular velocity, precession angular velocity. You can say precession angular velocity. Torque is equal to I omega p. Now, after finding the magnitude, what is the procedure to find out the direction of that reactive couple, a reactive force? So this procedure you have to follow while finding the direction of reactive couple in examination also as per given condition in problem statement. First step is draw three views of rotor showing direction of rotation, that is front view, top view and side view in three different plane. That means spin plane, precision plane and gyroscopic plane respectively by first angle projection method. In first angle projection method, we are doing top view exactly below the front view, right hand side view exactly left hand side view of front view, and left hand side view we are drawing right side of the front view, exactly right side of front view. This is the procedure to draw the three views by first angle projection method. Top view is always exactly below the front view. Now draw starting and new position of the rotor in precision plane. See here, in precision plane, you have to draw the starting position and final position of the rotor in precision plane. In precision plane. So you have to clearly understand which is spin plane, precision plane and gyroscopic plane by given condition in problem statement. Third step, find the direction vector OA and vector OB by right hand thumb rule. As I explained here, how to find the direction of vector OA and vector OB, whether it is direction from O to A or A to O, that you have to find out by a right hand thumb rule. Find the direction vector OA and OB by right hand thumb rule. Joint vector AB, which shows the direction of torque vector in precision plane. In precision plane, you will find out the torque vector. But that torque vector, active and reactive couple, you can see in third plane, that is a gyroscopic plane. So you have to convert that torque vector in third plane. So this is the next step, conversion of torque in couple. By right hand thumb rule, the thumb will show the torque and curving finger will show active gyroscopic couple, that is AGC. That you have to draw in third plane. When direction of vector AB is showing here, At that time, this direction is shown by thumb. So you have to draw this active couple with help of this direction by right hand thumb rule in third plane active force. That means this direction shows the thumb, and the curling finger will shows the direction of active couple. Active couple. And the last stage is transfer active gyroscopic couple in gyroscopic plane by looking from bottom to right. So this procedure you can clearly understand when you will solve the numericals. So this procedure we will follow while solving the numerical in next video. So at the end of this session, the student can understood how to find the magnitude and the direction of reactive or gyroscopic couple. Thank you for watching this video.